Okay, in this part of the video, I'm going to be doing a slightly more involved example that kind of demonstrates some of the more powerful abilities of R. Um, I'm using an example by Dale Rosenthal, who teaches Finance 310 at UIC. The majority of this code is his. I don't claim any ownership to it. I've only filled in some of the blanks to provide more meaningful data. But yeah, without further ado, I'll be using the Quandl library here, which is used to get a lot of the financial data that is going to be used in this example. It basically generates data sets for you for different stock or price indexes. So in your package manager, you want to make sure that you have Quandl. If you look for Quandl in packages, you'll have Quandl here. It also uses, so I have to import that. It also uses XTS and performance analytics. So you need to make sure those packages are imported. Okay, without further ado, the first thing I'm going to do is generate a tickers vector for generating the U.S. Treasuries. So I've already ran this code, so I have these data objects here. But if it was your first time running this code, you would see this list begin to populate as you run every line of code. So if I run this line of code for the U.S. tickers, as you see, it's shown on the console that are executed, and I have the ticker vector right here. You can see that it's a character type. There's 4 in here. I have it on grid display, so you have all this verbose display over here. But beyond that, the next thing I'm going to do is generate the U.S. Treasury's raw data using the UST tickers as a parameter and specifying the type as an XTS to generate the XTS object, which we'll be able to view as a table. So running that that line of code, I generate that table, and then I assign column names using the column names keyword, and I specify using our C binding that was mentioned before. Basically, a 3-month column, a 2-year column, a 10-year column, and a 30-year column. So we're just basically describing the time spans. So if I go ahead and execute this line of code, let me get my column names. I can see my table. I can see the UST.raw table. I guess I can't see it. Let me switch to list. Now I can see it. So this is the raw data. Once I run the log function and take the difference, I will get the log return, which is the, I guess, refined data. So running this line of code, I now have this data set right here. As you can see, they're different. I've basically just ran a higher order function on a larger data set. The next thing I'm going to do is I'm going to take the mean of every single one of these columns. So I'm going to take the 3-month mean, the 2-year mean, 10-year mean, etc. And I'm going to do it on the raw data, and what you'll notice is when I run these is I get values on the fly in my console. These are displayed right away, or executes line by line. I think it's pretty cool. The next thing I'm going to do is generate yield changes. This code is part of the example code. But in the same manner as before, we basically apply a higher order function and just assign that to a new variable. So I'm going ahead and run this code to get these objects into my list of objects so that I can work with them, so I don't error out later. And I can take the means once again. I can just run them, and I will get my answers right here in the console right away. So this is very useful in a financial setting where you're doing financial processing and stuff like that. Obviously, see, I have other higher order functions, so I have standard deviation, which I can run. I have semi-deviations, and so on and so forth. You can do skewness and stuff like that. But I'm going to move on, and I'm going to be skipping a lot of these higher order functions since most of them operate the same. That you can take a range and specify. It's kind of like SQL queries where you specify which parts of the table you want, but somewhat like that. So I'm going to take the Eurodollar price index here. So instead of using our UST ticker, I'm going to use the one for the Chicago Mercantile Exchange index for the Eurodollar. So if I generate that, I'm just going to show again. I only care about Seattle in this case, so I'm going to get this raw data, which you see shows that index, and then I'm going to take the log return of that, and that data you can see here. I'm going to assign column names and so on and so forth, just as I showed before. I'm also going to take the 2-year euro-dollar future price. If you see here, this is for 1 and this is for 24 months. I'm not sure why they go from years to months, but you know, that's just a naming convention. So I'm going to generate that data set too, and as you can see, you have these higher order functions that you can use. But what I wanted to kind of skip to and show was with all these data sets. So now I have Eurodollar and the U.S. Treasuries. I'm going to generate this S&P 500, Russell's 2000, and this energy index. I forget what the name of the actual company is, but it's an energy index from Yahoo. And I'm going to run this, and I'm going to generate these 3 data sets. And once my code finishes executing, I had some error, but I guess everything went through anyway. Okay, but moving on, what I wanted to show was that you can combine all of these data sets and create a complete data set. So as we used C to combine elements into a vector, now we can use cbind to combine a bunch of tables. So if I run these 2 lines of code, I'm going to get all data, which is full, and now I have data for everything, and you'll see this giant data entry here with 13,000 entries. But then I'm able to limit that by the years that I want. So all data, the not full set, I've specified data here from, or I've specified dates here from September 1st to 2012 to 2015. So I have that data, and you're able to filter in that sort of way. Yeah, that was kind of the big thing I wanted to show. Was there's obviously a lot more. I'm sure I could graph all of this stuff, and the important thing is that you're able to process a lot of financial stuff. It's very, I guess, you don't have to be a programmer necessarily to learn this stuff. I stumbled upon this language because I was tutoring somebody, and they needed help with R, and they've never seen code before. So it's something that is used not necessarily always in the computer science field. But beyond that, I also wanted to mention that R, UIC actually offers free courses in R. You don't have to be a finance major or anything like that. There's a CME-sponsored market training lab, which is, I believe, in Douglas Hall. And they also offer slideshows showing how to, there's different tutorials on the basics of R. So if you're interested, the resources are there. You can walk in on classes for free as well. You don't have to be enrolled in classes. So yeah, thank you for watching our presentation, and I hope you enjoyed.